To import numpy, you do import numpy as np. So because of the way we installed it through Anaconda, and we already have this numpy library with Anaconda. When you downloaded your Anaconda, some people might have to install numpy on their systems. So yeah, if you want to install numpy, if you don't have numpy, you have to do something like numpy pip, not pip, not we are using conda install numpy, but we don't have to go through. Just import numpy as np. That's how you import, then you can start using the numpy array. So to know the version of your numpy, just do numpy.np. That's np now. So since we are importing numpy as np, so np is now stored in memory as something. So you could do np __ version _ to get the version of your numpy. So my version is 1.21.5. So you could do that to get your numpy. So with numpy you can work with different things, different data types. You could work with integer, booleans, floats, but for now we'll just be sticking with integer and floats. Yeah. So to create a numpy array, you use, so let's say let's make our a is equals to numpy, so np.array. So remember I said we work with lists, so you can say 2, 3, 4. So this is, so if I print type a, it's going to return it as a numpy array because it's nd array, so n dimensional array. So numpy saves things as n dimension, so it saves it as n dimension array. So to check the dimension, because you could have multiple dimension, you could do a.ndim. It shows you that it's one dimension. So before we go ahead, let me give you an illustration of the numpy array. So if you see this, you remember, I don't know how many of you remember your mathematics where you have vectors and metrics. So vectors when you're dealing with just a kind of row or a column. So this is one dimension. When you have just one row or one column, you call it a one-dimensional Python numpy array, right? And you just have one axis. Yeah, so by the time you print the shape, for example, if you print the shape of this, you see that it's one, so this shows one dimension, one, and it has 3 columns or whatever. This would be 3, 1. Then we have what we call two-dimensional array. So we have it in this, and this is more like your table, your spreadsheet, where you have your rows and columns. So if you print this, it's going to show you this. The shape of this is 3 by 3, but it shows you have 3 rows and you have 3 columns. And remember when we did indexing, so your row has the axis of your row is 0 and the axis of your column is 1. So you have to put that in mind. Then we also have 3-dimensional array. So you have it's more like having length, breadth, and height, something like that. So you have your row, column, and you have this your axis too. So just have this picture in your head while we go forward. So now I said, okay, let's print a.shape. So a.shape shows you the shape of your array. So I have 4. By the time I print a, for example, you see that it's 1, 2, 3, 4. Then we could also, before we go into reshape, let's create a 2-dimensional array. Yeah, so it can get confusing here, but just trust me and flow along. So to get a 2-dimensional array, you do this. So you have your main bracket square, then each of the dimension we have their own square bracket. So you could do 1, 2, 3, 4. Then we have a comma, and we have, let's say, another square bracket. We have 5, 6, 7, 8. So by the time I print out my B, what does this bring out? So it brings out, so I have it in, it's more like now I have 1, 2, 3, 4, 5, 6, 7. So I have 2 rows, but 4 columns. Each of them represents. So if I print out B.shape, it gives me 2, 4. So 2 is the number of rows. My 4 is the number of columns I have. I can also do B dots n dimension. So n is like number of dimension. Just like a 2-dimensional array. Then let's try a 3-dimensional array. So I do np.array square bracket. I do this. I have 1, 2, 3, 4. So just stay with me. This can get confusing. So this is, so now this will look like a 2-dimensional array, right? So we'll see how we convert a 2-dimensional array. I would do from 2 dimension to 3 dimension. Yeah, so we have 5, 6, 7, 8. So you see, like, this is what we have as 2 dimension. So basically I can now put a square bracket like this, and I do, yeah, a comma like this, then have, so I have my 7, 9, 1, 2, 3, 9, 10, 11, 12. Then I have 13. Okay. This 13, 14, 15, 16. I know this the 20 square brackets can make it really confusing, but let's just break it down gradually. So what do we have? So it's like having two-dimensional array. So this is the first two-dimensional array we put. Then this other one is like having it at the back of that one. So now you're making it, you're introducing a 3rd dimension to it. So initially what we had was this. Now I'm introducing another 2-dimensional array at the back, so make it like 3, make it a 3rd dimension. So that's what you have here. You have this, just see this as the front, and this one at the back. This one at the back of this. You get one easy way I used to know how many them. So for example, for 3-dimension, c.end them, it should show you that this is a 3-dimensional array. One easy way I used to know, because at some point this can get confusing. By the time you count the bounding bracket at the last and the first, this is 3. This is 3. It shows me that it's 3-dimension. That's my trick to understand dimensions. So if you look at this one, this is just 2. It's 2-dimension. And if you look at this, is 1. So that's my little trick, so that it doesn't get confusing.